All right, we got another captain's log. This one's going to be on types of robots. I was going back and forth on whether I wanted to be two videos or one video. I think we're going to try it as one video. So both types of robots and then going through and analyzing how you'd pick out what type of robot you want to build for your season. So I know for this season, or the year that I'm recording this video in, it's already started. So you might feel a little bit behind, but there's still plenty of time to build whatever robot you kind of want to build, and then build the attachments or additions to it to score points. So I have four different types of robots, four categories. There's a bunch of different types in them, and this isn't like an end all be all list. It's not an official list. This is just what I think of when I'm categorizing robots in FLL. Um, and again, a lot of these you won't see. I'm just gonna be honest. Um, I'd say that especially once you get to like regionals or sectionals, you're gonna see 95% attachment robots, and maybe 5% of like platform robots, and probably you won't probably see anything else at all. But that doesn't mean that they don't exist or that they're not something that could be super useful. Um, there's some issues with attachment robots that not a lot of people talk about, and I just want to make sure that you're aware of all the different types of robots that you could build, so you can make an informed decision on what type of robot you want to build. Right. So just going on the list here, we have single-use robots. So these are robots that you don't put attachments on or anything. You can have different programs and different runs, but the robot just is what it is, and you just hit the play button on every mission or on every program, and it goes out and does whatever missions. Um, it might be confusing at first, like how could you make that work? But there's three different types of those ones that are various levels of making it work. Next, we have attachment robots. So sometimes you'll hear these called like dog ear robots or um, like box robots. I put them as attachment robots because dog ear and box robots are usually like that's just like a defining factor of what the robot looks like, but they don't have to be a box shape and they don't have to have dog ears. So I like to kind of just categorize them as, just robots that you put attachments on. So these are robots that can't really do anything on their own, right? They can drive and do all that stuff, but there's no arms or levers or any attachments on them. And so you have to build an attachment and place it on top of it or, connect it to it or something like that. Next, we have core robots, which are kind of like inverted attachment robots. Um, you place the robot inside of the attachment or like on top of it. Um, there's not a whole lot more to say about that. If it's confusing, I'll show you a video of it later. They're very, very complex. I never built one in competition, but just with playing around with them, they're very, very technical to build attachments for and to design the core robot itself well. Next, we have hybrid robots, which I've three categories of. Um, they just combine two other robots, to put it simply. These ones are, not they're not always like super their own category. Sometimes they look identical to like an attachment robots or to a single use robot, but then they have like something that just can't quite fit them into those categories. So platform robots, this is platform robots are actually what I might recommend you guys use, especially like new-ish teams. Teams that are either brand new or have a year or two of experience, platform robots are really underrated. Um, there's one main permanent system that things are attached onto. There's a wide variety of what this could look like. It could be. I'll get into this later, but like a lift is a seriously underrated um, like platform to be building on, and would be definitely something to look at. Superstructure robots, it's kind of just a feature that you can add to basically any other robot pretty easily. And this is just where you put gears on the bottom of your robot that can attach on top of an attachment. So it's like making an attachment robot into a core robot. And I'll show you a video of that too. They're pretty cool. They're again really hard to design around, but these ones give you more flexibility and are more forgiving than core robots. So there's limited uses where they'd be super important, but there's always a few, and so it's good to know what they are. Then finally, mixed robots. So they have a permanent single-use attachment or even like a platform, as well as an interchangeable like attachment side. So sometimes it's like front and back. So you maybe have a lift on the front and then an attachment slot in the back. So think of your robot you built last year, but instead of on one side, instead of having the gear, you just have like a lift or some other like permanent structure, which would be what a mixed robot is. And mixed robots are also very underrated and can be used very well for a lot of things. And I'll get into why in a little bit. Now, if we just we're just gonna go through all these now. So I'll try to leave timestamps at everything. So if you're interested in a certain part, you're like, oh, we would never do this one, and so want to skip it, I'll try to put those in there. But single-use robots, I put them into 3 types. So one is literally just what you're thinking, like it's got like you just have like a lever on the front or something, or like yeah, like there's just a lever on the front, and you're completing like maybe 5 missions. So this is when you have like a big inner team. So you might see this at like your first competition, like if there's a super new team, um, and they have like just the core kit or something. A lot of times you'll find just like a super simple robot um, that just does as many missions as they can. It doesn't have a great ceiling, right? Because there's not a lot that you can work with there, but it's a decent start. Number 2 is like you have a solid function. So I'm thinking like a lift, or some sort of like pretty versatile like arm or a lever that can do a lot of missions. And so you're more focused on like the programming side of things, and you can do pretty well with those ones. But again, these 1 and 2, I wouldn't recommend, um, unless you're like, you started in November or something, and you only have like a month for whatever reason. And then third, these ones are just cool. I like them. They're the one run robots. I would not try to do this for a competition. They have a pretty hard ceiling, and they get really really hard. We'll watch a video of one, just because I like them. But it's a robot that exists. You probably won't see them anymore. Um, but it's like a kind of just a fun challenge robot that people build sometimes. Um, what it does is it usually just drives in a straight line. So one motor's running the wheels, and you have 3 motors that just run lifts, or I guess rack and pinions across the board. And there's a lot of like passive mechanisms that go off as you're going across the board. Um, but yeah, I wouldn't recommend those ones either. So all in all, I wouldn't recommend building a single use robot, unless you're really confident in your ability to build a um, one run robot, or have a solid function that you don't even need to put attachments onto for whatever reason. Next is attachment robots. So I put a star next to this one because these ones are the most versatile robot you could build. Attachment robots, they can quite literally do any of the missions. Um, and the only reason you would not build an attachment robot is if something else is easier, right? So there's not going to be another robot type here that can do more missions than attachment robots, um, especially if you make them into like a superstructure robot or something. But you just slip on attachments like you did last year, and you can build whatever attachment on top of this robot that you want. And so that's why it's so versatile, is because you can quite literally do anything on top of your robot. Um, the only reason I wanted to make this video is because attachment robots, I just want to point out the fact that they're not always the best thing. Okay, you'll see a lot of videos online, and a lot of like teachers and stuff, and the general consensus is that you have to be building an attachment robot, right? And it's a good robot. Don't get me wrong. It's gonna be the best robot, or it can do all the things in 100% of the cases. And that's why people tell you to build them, because they're so versatile. But I'll give you an example. Um, about so my last year, my 8th grade year, we were building a robot, and it turned out that almost every attachment we were going to put a lift onto, so a rack and pinion up and down onto. And at that point, it would have been easier to just build a robot with a lift on it, because every single mission that we were doing required a lift, right? Or would have been completed with a lift. So we ended up building 3 different lifts on attachments when we could have just built one lift on the robot and made super simple, just, you know, putting a beam onto this. And I'll show you another year where we did that, because it's just so easy, right? There's no reason for us to really build an attachment robot, because we were just using a lift component over and over and over. So I just want to make sure you recognize that there's other options that are easier than attachment robots that very well could get you the same or more points, because the learning curve is lower, it's faster to get going, they're oftentimes equal to program, um, and so you're not going to be limited by a bunch of other robot types. And I just want to point out that fact that you'll see a lot of people vouching for attachment robots or these box robots, but they might not always be the best for your team, right? Next, we have the core robots. I kind of talked about these, but a lot of times you'll see them with 4 medium motors on the bottom and the brain on top. A lot of times they'll like put color sensors on the bottom too, and they just slide um, into the attachments. You have, crazy amounts of customizability. You can have 1 motor run the wheels. You could have 2 still. You can build the chassis of the robot however you want every time you build an attachment. Um, and so it's like the attachment robots on steroids, right? But they're super hard to do, right? To even get them to like score points, it takes a lot of work, and a lot of effort, and there's a really big risk of not being able to reach your full potential, because they're just so hard to make work. Um, so if you have a lot of times the teams you'll see doing them, they do a core robot every year, and they've had the same core for the past 5 years since Spike Prime came out. And so they're just used to building with it, and they have a lot of customizability with it, is what you'll see. So I'll show you a video of those ones too. Then on to our kind of mixed ones. Platform robots. I started this one too, because they're super underrated. I'll show you a couple of examples of them. But like I said, they're still capable of completing a lot, if not all of the missions. One, sometimes both of your medium motors are used on like your main mechanism, whether it's a lift, a double lift, or some sort of like arm structure. I'm trying to think of what other types of mechanisms you could use. I guess sometimes you have like different gearing. So I didn't put a video of this, but if you look up like Orca shifter or quadbot concept on YouTube, um, there's ways of turning two motors into four outputs, or in the Orca shifter's case, 15 outputs. And so there's, you're building on top of this platform, or mechanism in the case. So, I've built a robot with a shifter that has like, a lift on one side, still two attachment bays, um, and then it's got like just an arm in the middle. So there's a lot of different things that you can do with platform robots, a lot of like combinations of mechanisms. Um, and so I really want to like stress this one to you guys, because platform robots are pretty easy to do. I'll show you an example of a robot we built, Minion, with a lift. And they're just simple, right? We we didn't use a second motor until like we used it for one mission. And otherwise we just used this lift up and down and scored like 400 points, right? And so even when compared that to all the other seasons that I did, it wasn't like that much worse than a box robot, and it was so much easier to do. So it's something that like you definitely want to be at least thinking about, does a platform or even a mixed robot make sense for our team? Superstructure robots, um, they're something that if you want to try, it's pretty easy to implement them into an attachment robot or to a platform robot, um, especially on like just putting them on the wheels. Sometimes putting them on the medium motors can be hard depending on how you build your robots. Um, but I'll just warn you about the superstructure robots. They can seem really cool and like they have a lot of opportunities, but when you get down to it, you might not use it. Like I've built robots. This one was called Sprinkles, and I put a superstructure in it so that I could connect to, put on top of a superstructure. And I just never used it, right? Our team, we just never needed to use it, and so it just was there and wasn't used. Um, so a lot of times it's just better to just not have it, um, but it's something that you can pretty easily add into most other robots. Finally, mixed robots. These ones are very similar to platform robots. It just is the mix between the platform robots and the attachment robots. Um, so if you're worried, like, hey, this lift is great, but or this lift or whatever mechanism you put there is great, but we still want the versatility of having a slip-on attachment, you can just have one motor running a slip-on attachment on one side and a lift on the other. Or you could have that slip-on attachment on that permanent mechanism. So sometimes you'll see, I'll show you a moving wall robot, and it has the medium motor inside of the lift. And so instead of running another lift, you can just have that medium motor running slip-on attachments on a lift, um, which could be kind of cool, right? So just a review, I got some pictures down there too. I guess I can show you those. But platform robots, attachment robots, or mixed robots, I think would be the most versatile. I would stay away from the super complicated core robots. And I think all the single use ones are just too limited. You at least want to be able to put stuff on those solid functions as attachments. We're going to skip those. We're just going to go to the videos I have prepared. Okay. So we're going to do some kind of video analysis. The first video is from the Wearing Brick Wolves. This is probably my favorite FLL run of all time. We're not going to watch the whole thing, but if you're interested, you should definitely go check this one out. But they have the slip-on attachments. So this is a textbook example of those slip-on attachments. Let's see if we can find another spot of them slipping on their attachment. So right here, attachment comes off, attachment comes on. So if we just look at this front here, theirs looks pretty complicated and pretty intimidating, right? But what's happening is, if you can see my mouse in the middle here, they have two gears that are hidden right here that come up off the robot, and they mesh in with gears on this yellow attachment. So this yellow attachment has gears that sit right next to them, so right here, and then come straight up into more gears and are geared over to whatever else they're doing, right? And so this gives them the versatility to do whatever they need to be doing. So in this case, they have a wedge that lifts up and down. They have little kickers here that'll knock over some posts. So if we watch this here, you'll see them come up and power's transferred all the way into this wedge here, and it kicks it up, right? They'll keep going on their mission here, and they'll go over to this like demolition mission, and it'll kick out those little supports and grab this guy. So having the box attached, or the attachment points on them, allows them to both do that and then also be able to do any other mission they have, right? So now in this one, they have, a little kicker on the side and a little drop off on the other side, right? So having both sides is really, really helpful there. And I will say, when you're building attachment robots, I'm always partial to having both of them on the front. I know last year you had one in the front, one in the back. That's fine. Like, that's a fine design. I just always like having things on the front of the robot, because then you don't have to turn all the way around. It just is kind of more natural if everything's in the front, because that's the way your robot's driving, right? So here they can drop it off, and it's both on the front side. They don't have to like turn around to drop off the second mission that they're doing. They're both on the front. I'm more partial to that personally, so that's always my opinion, is having both of them on the front. But yeah, so that's an example of the attachment robots. This one right here is going to be an example of the superstructure robots. I don't know if these guys are still competing. They're from, I believe, Germany. But it's, again, another example of a attachment robot. And they just have a lot of, things. They can just slide it onto their robot, right? And you'll see how effective that can be. But what we're really looking for here is this. So we're going to come back, slide their attachment off. And this attachment they go on top of, right? So this is what a superstructure robot is they put the robot on top of it, and all of their motors have gears in the bottom that can kind of mesh with, let's see if we can see them here. There's gears underneath there. So there's a platform they put it on that the gears all mesh into. And as they're running, you can see they have a bunch of different motions that they can do as they slide over this green platform here. So the reason they built the superstructure is so that they can go just in a straight line and go over top of this green structure, right? So green structure is there to kind of hinder people like driving in that area, right? You'd have to go around it, but they just went over it with their superstructure. So it's something that can be of use, right? But obviously, this looks really intimidating, and it is. It's a very, very hard thing to pull off, and a lot of times just not really worth the effort, unless you're like them and going for like a world record amount of points and just need something to go on top. Next, Next, we have a core robot. So you'll get to see this team only does core robots. And right now the robot looks, pretty standard, albeit a bit tall. But you'll be able to tell quite like when they pull it out, it's a very unique looking robot. So they literally just pull it out. You can see they have color sensors on the bottom there, and then medium motors on the sides that just mesh into gears for the wheels. So in most of their cases, their core, like their attachments, all look very similar and have almost identical drive bases, right? Those 62.4 millimeter um, tires, and then the fat wheels with no rubber on them. But what this allows them to do is just have really unique mechanisms and build in a really unique way. That'd be really hard or almost impossible to do if you didn't have a core robot. So we'll see in their next robot, if you just look at the side of this attachment, like this mechanism is never really going to fit in an attachment robot. Like you're not going to put that onto an attachment. So it's kind of imperative that they have this core mechanism to be able to do that. But again, it's not like this mechanism here that they have on the side is not required to complete the missions that they're completing. It's just it allows them to do whatever they want. They have a lift on one of the wheels or on one of the motors. They have this mechanism. I'm assuming this like turns two motions into um, a couple or something. I don't really know. I haven't dove too deep into it, but it allows them to just do so many things in such a unique way, and kind of solve missions however they want. But yeah, so that's what the core robot looks like, sliding in and out. Next, we're going to look at, I believe this would be a platform robot, because I think they take things in and out of this wall. But this is a kind of a moving wall design. We'll see another moving wall in just a second. We'll briefly touch on that. But there's an up and down, so an up and down lift, as well as an out and in lift. So there's a pincher that goes up and down with this wall. So all of their attachments are passive attachments. A lot of wedges, a lot of like trigger mechanisms. But they complete 500 points with just this one single mechanism, right? It's a pretty complicated and intricate mechanism, right? Going up and in and out. But there's no like motorized attachment points, like a lot of people will say is a must. It's just this big lift on the front that they can do a lot of things with. It's a very versatile mechanism to be able to go up and down and in and out. So you get the in and out and the up and down. They do take things on and off of this, so technically this would be classified as a platform robot, but it's very, very close to being just like a solid function, single-use robot, right? But like that's something that could be made. There's a lot of tutorials though online for these moving wall robots. There's some for Spike Prime as well. And this one just goes up, down, and side to side. So there's no pinching. But this is the year, so this is my 8th grade year. And this year, it just, so many of these missions you could do by just driving into them and having a lift up and down, right? So we did an attachment robot this year in Cargo Connect, but we ended up just putting a lift on half of our attachments. And so instead, you could just build your robot with a lift in it and score 525. All right, my recording cut out, but like I was saying, this lift was like completed almost every mission in this year. You could either do like just passive mechanisms that the robot pushed or a lift, and you could complete everything. Um, Technically, the max points were 700. Really, it was 680, but you could finagle 700. Um, but 525, that's a really good score for this season and would be like top of states just off of this one mechanism, right? There's no attachment robot here. It's just a lift. It goes side to side, but even a lift, I would think would be pretty versatile in this season. The side to side definitely gives you some advantages. Like they can follow this line on the right here and still move their lift to wherever they need to go um, to pick up those blocks. So it's a kind of a preference on what you would want there. But again, just consider these lifts. I'll show you our team's lift in a second, but the last one I want to show you was the single run robots. Skip to where it starts. Right about here. So it unfolds, and they just have this huge lift that just goes across the board, and they just drive forward and backwards. And it's just a really cool thing. Again, we won't watch the whole thing, so if you want to watch this on your own time, that'd be a good idea. But they can just go across the board. They never touch this robot again. Um, and it's just I just want to point out that it's a robot that's out there um, that can be built. A lot of these principles can be used though as well. Um, the side to side lift is a pretty big thing that can be helpful. And if we go back to right about here, these passive mechanisms can be huge. Like this is something that you would probably need a motor in most other cases, but to be able to just drive on by it and drop off that water is a huge thing that you want to be making sure that you take into consideration when you're completing missions. And finally, we'll go over some robots that I've built. So this is the cargo connect year, so my 8th grade year. And this is just an attachment robot, right? At one point, this guy was flipped up. I'll show you that in a second. But you just have these 2 gears on the front here that we could slide attachments onto. The other gear would go in this little hole right here. But yeah, we could just put on attachments and they would mesh with those gears. So it's a very compact robot. It was only 17 studs wide, which was pretty much the slimmest you could get a EV3 robot to be. I think there's designs for 15 wide spike primes, just because the components are smaller. But this one was our last robot. Down at the bottom, some of this doesn't apply to you, but we had our gyro sensor in the middle. We use those 26.4 millimeter wheels. Might talk about wheels in a future video. Color sensors in the corners. And these are the medium motors that powered the top. So you can see we bevel geared them straight up and down, and then they would just come up the top, right? And that way we could transfer the power from these medium motors to whatever attachments we wanted to build on there. This picture, eventually we tilted our our brain up so that we could put a color sensor there. That was one of our kind of innovations that year, is we added a color sensor to detect what attachment we had on. But this is, a attachment we put on top of it. So you can see, I have to remember what this even did. We had an axle that came across here to lift this little lever and knock down the train track, I believe. This would drop off the cargo into the train, and this guy back here would push the train. These two right here. So these are all geared from this front here, and we could kind of, get all the motion from just that center to wherever we needed it to be. But finally, this is Minion. Yeah. So right here, this was my 6th grade year, and we just built a lift. So you can see another motor on the side here. This motor we added like 2 weeks before our competition, our third competition, and it only does one mission. It just does the demolition mission. But otherwise, all of our attachments were put on this center lift. So we had two side-by-side lifts that just lifted our attachments up and down. And this, for what it was, did so much and was so useful, because it was super simple to build on. Like anybody could build on it. You just put an attachment in there and it just went. It could go up and down. And so then when you were programming, you just had to drive around and go up and down. It was super easy to program. It was super easy to build onto, especially for a lot of the things that we were doing that year. It just worked out really well. And I would really urge you to consider some of these like simpler robots that have just really robust systems on them, especially the lifts. You can go as simple as just a lift up and down, like we did here. You could expand it left and right or whatever you wanted to do, or you could be looking at, a more complicated lift, either like this one, the up down and pinching, or even the up down side to side, or moving walls like that. Those are all things that I would heavily consider when you're trying to select your robot for this year, just because the attachment robots are really nice, and can do a lot of things. But if you think, hey, this lift up and down, this motion can complete all the missions we want to do, it's that motion is already built into your robot, right? And it's really robust. It's not going to slip because it's not an attachment. So it's just something that would ideally work every time, right? That's about all I have for this video. I know it's a long one. I'll try to add those timestamps. But yeah, thanks for watching the second Captain's Log video about types of robots and robot selection.